Hello everyone, welcome back to my YouTube channel. My name is Sagar Udekar and this is day 4 of our free CK series. In previous video, we discussed about how to set up local cluster using Minikube. And today we are going to discuss about how to set up multi-node Kubernetes cluster using KubeADM 2 on AWS Cloud. This is very important topic for your CK exam as well as for your Kubernetes interview. So without ado, let's get started. This is what we are going to design on the AWS cloud provider before jumping into KubeADM utility. Okay, so we are going to create one VPC for our Kubernetes cluster, and the CIDR range which we are going to use is 172.31.0.0/16. This will provide us more than 65,000 IP, which should be enough for our usage. Then we are going to create subnets, public subnets and the private subnets. In the public subnet, we will add our Bastion host, which will access our Kubernetes cluster, as well as in the private subnet, we are going to create our Kubernetes cluster nodes, either be it control plane node and the worker nodes. These are the specifications for our Bastion node. We are going to use instance size t2.micro, and then we will create a separate security group for managing the inbound and outbound rules of our Bastion node. As we discussed, we will put our Bastion node into public subnet. Next is we are going to create one single control plane node with the instance size t2.medium. We will create a security group for managing inbound and outbound rules of our control plane node. And we will use private subnet for control plane node. The next is we are going to create two instances of the worker nodes using instance type t2.micro, and we will create worker node security group for managing its inbound and outbound rules. Similarly, we are going to use private subnet for worker node. These are the prerequisite from Kubernetes official documentation. A compatible Linux host, 2 GB of RAM, 2 CPUs, full network connectivity between all machines in our cluster, a unique hostname and MAC address, and product UUID, and certain ports needs to be open. Obviously, since we are going to create a Bastion host which needs access to our control plane and the worker node, we will provide a SSH access from a Bastion to our Kubernetes cluster nodes for setting up different components of our Kubernetes cluster. Similarly, on control plane and the worker node, we need to open a couple of ports for different components to work, such as 6443 is a port of Kubernetes API server, which needs to be accessible from all Kubernetes cluster nodes as well as from outside. The next port is 2379 and 2380, which is the etcd client server API port. It needs to be accessible from API server and etcd. The next port is 10250, which is the kubelet API port. 10259 is a port of our kube scheduler, and 10257 is a port of our kube controller manager. These many ports we need to open on the control plane node, including SSH port, as well as I have added one node here. We need to open 6783 TCP port and 6783 and 6784 UDP port for VMnet CRM on control plane and the worker node. Let's check which are the ports we need to open on the worker node. So port 10250, which is a kubelet API port. 10256 is a port of kube proxy. And this is a node port services range 30,000 to 32767. This port range needs to be open for all, and these are the ports we need to open on the worker nodes. The next thing is we need to update host names and perform multiple operations on our Kubernetes cluster nodes. So without ado, let's jump into the actual practical. Okay. So first we are going to enter into our AWS account and start creating VPC. You can search for VPC service on your AWS account and give a user-friendly name. The next thing is we need to set the IPv4 CIDR range. You can use the CIDR range for your Kubernetes cluster. Okay. We will use two ASIS, two public subnets, and two private subnets. And we will also create one NAT gateway in one ASIS. The rest of the details we can keep same and hit the button of create VPC. This is VPC workflow creation process. It is creating VPC along with subnets, internet gateway, NAT gateway, and it is going to associate route tables with all the resources so that we will have the required internet access on our public instances as well as private instances. Okay, this will take some time for the entire VPC workflow to get finished. Meanwhile, we can go to our EC2 service and start creating Bastion and other Kubernetes nodes. So I'll search just for EC2 service and come here and then click on the launch instance. I'll give a name to my Bastion as Bastion. Select OS image as Ubuntu. Instance type is t2.micro. You will see here we are getting one CPU and 1 GB of memory. This should be enough for Bastion. Okay. Then if you don't have pre-created key pairs, then you go here, click on create key pair button, give a name, and it will create a key pair for you, as well as it is going to download one PAM file on your local machine. Since I already have PAM files created for Bastion host and the cluster nodes, I'll use those. For Bastion host, I'm going to use a Bastion host key pair. The next very important thing we need to understand here is whenever we are going to create any node, AWS will set a default configurations for the networking. We need to update those. So click on the edit button and select the VPC which we created. So this is our VPC, Kubernetes VPC. Similarly, we need to make sure we are using public subnet for our Bastion and enabling auto assign public IP here. Okay. The next thing is we need to create security group for Bastion and provide SSH access only from our machine, my IP. Okay. The number of instances will be one, and that's it. Click on launch instance, it will create Bastion host for us. Once you create, once you come here on the AWS EC2 instances page, it will show you that instance is getting created. It will take a couple of minutes. Meanwhile, we can start creating control plane. Again, same process, click on launch instance and type the name of instance, control plane. Number of instances will be one. OS image is Ubuntu. Instance type for control plane, we are going to select T2.medium since we need at least two CPUs and 2 GB of memory. And then we are going to select key pair cluster nodes since this is a part of Kubernetes cluster node. Okay. Update networking settings to change VPC to Kubernetes VPC. subnet. This time you will see here, it is selecting public subnet, but we need private subnet. So change this to private subnet. Auto assign public IP will be disabled. We don't want public IP for our Kubernetes cluster nodes. And let's start with creating security group as well. Okay, here you need to understand we don't want to provide SSH access to our Kubernetes from nodes from anywhere. We want to limit SSH access only for Bastion. For that, change source type from anywhere to custom. And in the source, you need to start typing Bastion, which is a security group attached to our Bastion. Okay. So this will provide SSH access only from Bastion. That's it. Now click on launch instance. It will start creating control plane node for us. Perfect. One more step done. Come here on the AWS EC2 instance page. Our Bastion is ready. Control plane is getting ready. Meanwhile, we can start creating worker nodes. As we discussed, we are going to create two worker nodes. Provide a name to your worker node. Select the operating system image. And instance type, we can use t2.micro. This is just for practical, right? Key pair is cluster nodes key pair, since these worker nodes are also part of our Kubernetes cluster. Same, if we need to update VPC, select VPC, Kubernetes VPC, change the subnet from public to private. Auto assign public IP will be disabled. We need to create security group for worker nodes. Limit the SSH access only from Bastion. And that's it. Click on launch install. As you can see, our nodes are getting created. Let's wait for a couple of minutes for all these nodes to get restarted. Meanwhile, we can check our VPC workflow is completed or not. Great. This is our VPC and it has been created. The entire VPC workflow is created. If you come here on VPC page and select Kubernetes VPC, you will also see your resource map. So this is our VPC. Let's check here. This is our VPC. Okay. So this is our VPC with 4 subnets, and for public subnet, you will see it is referring to route table, public route table, which is integrated with internet gateway for providing the internet access to all the instances which are part of this subnet. And for private subnet, we are using private route table. And if you see this graph, it is connected to NAT gateway, which will provide public or the internet access to the nodes which are there on our private subnets. Okay, this is done. I think we are good for now. The next thing is I want to change the names of these worker nodes from worker node to 1 and 2 for easier understanding. So let me update those. Before all the next steps, what we are going to do, as we discussed, we need to provide couple of access or open certain ports on control plane node and the worker node. So we will start with opening ports on control plane node. So for this, we need to update the security group attached to our control plane node. Let's get started with our Kubernetes API server, and this needs access from everywhere. Since API server will be should be accessible from the components of Kubernetes cluster as well as from the outside. So 6443 port, select the control plane mode, and then security tab, and select a security group of your control plane mode. Okay. Click on edit inbound rules. So far, we only have provided SSH access from Bastion. The next thing is we need to add 6443 port access from everywhere. Okay, check the next port, which is a etcd client server port 23792380. 23792380 needs to be accessible only from control plane, right? If you remember, and etcd is accessible only to Kube API server and itself. So we don't need to provide access to etcd client server from everywhere. Okay, next. Next is Kubelet, Kube Scheduler, and the Kube Controller Manager port, which needs to be accessible from the control plane and the component itself. So 10250, 259, and 257. 10250, 10259, and 10257. This needs to be accessible from the control plane. Okay. Similarly, as we discussed, we need to add couple of TCP and UDP ports for WebNet CNI to work. So to add a port to 6783. This is the TCP port and UDP port 6783, 84, 6784. Okay. These are the inbound rules for our control plane group. We need to perform same action for our worker nodes as well. So for that, you can select any of the worker node and select a security group attached to the worker groups. Start editing the inbound rules. We can start with a VNet CNI port as a 6783. Needs to be accessible now from worker node only. UDP port range 6783.84, 6784. Make sure you are adding correct sources as well. Okay. The next thing is we need to add 10250, 10256 port, which is a kubelet and kube proxy port. Okay. So 10250. This needs to be accessible from control plane as well as worker node. You will see that it is used by self, kubelet API, and control plane. Okay. So the next is we need to add 10256 port, which needs to be accessible from the worker node as well as load balancer. So what I'll do, I'll add the port 10256, which needs to be accessible from the load balancer. So maybe we can open it either for now, just open it for control plane and worker node. And this is the port range which we need to open, 30,000 to 32767. This is the port range used by our node port services. 30,000 80,000 to 32767 is a port range by the Notepad services. We will discuss about different types of services, but for now, this needs to be open for everyone, not for workers. So I'll update this source to everywhere. Okay. Similarly, kube proxy, yeah, I think this is good for now. So let me save this, and we are good on all these instructions. So we created VPC with the CIDR range. We created public subnet and the private subnet. We created Bastion host, control plane node, and the worker nodes. After that, we added the required ports on control plane and the worker node. The next thing is we need to update the host names on all the nodes. So I'll show you how to update host name on Bastion as well. And then we will perform the same operation on all our Kubernetes nodes. So let's go to our Bastion. Okay. Select the Bastion node. Select the public IP address of the Bastion. And then we will go to the local Bastion terminal. Okay. For accessing a bastion, we will use a SSH protocol. So start typing SSH -I, the key pair of the bastion. So bastion host, username, Ubuntu @ the IP address. Perfect. So now if you do the host name, it will show you this is IP address, but we need actual name. So we can start editing one file which is present in etc folder. So just type etc vi/etc/host name. This will open the file where the host name is set. Delete the content of the file and update the file by going into insert via editor insert mode and type the name of the host which you want. Save the file content with the colon WQ exclamation mark and then reboot this machine. The same thing we need to perform on our control plane as well as worker nodes. So we will wait for these nodes to get restarted, Bastion node. Once that is done, we'll log in into control plane and the worker nodes from our Bastion. Okay. Okay. You'll see here it is taking some time for actually getting rebooted. Once that is done, we should be able to see the new host name. That's it. All these instructions I have put on the GitHub README as well, updating hostname. So we need to update etc hostname file with the node name and restart the nodes. We are on this stage. Let me check again. Okay, now we are into Bastion, and if you type hostname, you will see the hostname has been updated. So what we'll do, we will try to log in to this Bastion from 3 different terminals. From each terminal, we can go into control plane mode as well as on the worker nodes and update libraries. So whenever you want to, let's see. I am using this command, this terminal called terminus, which help me to check the split view as well as I can copy paste the command or replicate the commands into multiple terminals. Okay, if you are using Windows, then you can use a mobile external as well, which provides a similar feature. Let me turn on the broadcast input feature and see if this works. So we need to log in as a root user and SSH. into control plane node. So first terminal we will use for the control plane node, and these two terminals we will use for accessing our worker. Whenever you want to replicate any command, you can turn on the broadcast mode, and when you don't need, just click on this icon and it will disable the broadcast mode. Okay, I'll disable it for now. sh-i, and then to access the control plane node or um, any cluster node, we need to have the key pair similarly as we had for the bastion. So what we will do, let's copy that key pair from our local machine inside the bastion. Okay. So you can use the scp command and scp bastion host dot parent and the file which you want to copy inside a bastion. Okay. And the path where you want to copy it. I want to copy the file in this directory. Yes, so this is a complete command. You need to know at least SSH and the SCP command for these two. So SSH command, what we do, we are accessing our bastion host using SSH hyphen I, the key pair name, and the username at the rate IP address. Okay. And to copy any file into remote machine, such as bastion, what we did, we used the scp command, scp hyphen I. And to authenticate to the remote host, we need again keep your name. After that, we are putting the file which we want to copy inside the remote machine. Similarly, the next thing is Ubuntu, which is the username at the rate IP address folder, the file path where you want to copy. So let's uh, go inside our bastion now with the SSH command. Okay, and this time what we'll do, we will provide the IP address here of the control plane node. Here we will provide the IP address of the worker node 1 and worker node 2 here. So since we don't want to replicate, we will disable the broadcast input option. Let's check the IP address of our control plane and worker nodes. So select the control plane node, get the IP address from your AWS account. Okay. Similarly for worker node 1 and worker node 2. Perfect. So let's log in into our Kubernetes nodes to set the host name. Okay, we are into the machine. Let's enable the broadcast, clear the terminal, and enter as a root user. Perfect. We will start editing the etc hostname file. Now we need different host names for our machines. We disable the broadcast input and enter the respective host name. So here control plane, save the file and reboot your control plane node. Okay. Similarly, set worker node 1 and 2. Reboot these nodes as well. Perfect. So this is going to take some time to reboot the machines. And once that is done, we will follow next instructions on all three nodes. So let's get back to our documentation and see what are the next steps. So we have completed updating host names on all our Kubernetes as well as Bastion hosts. The next step is execute all these commands on cluster nodes as a root user. So we need to disable the swap space first. So let's wait for our nodes to get restarted. Okay, perfect. So control plane is ready. Our worker node 1 is also ready, and worker node 2 is also ready. We can enable the broadcast mode, clear the screen, and enter as a root user with the sudo su command. Perfect. Type the command to disable the swap space. This will disable the swap space on all our Kubernetes cluster nodes. Okay. The next thing is installing a supported container runtime, container D with runc. Okay. So as we discussed in one of our previous video, in Kubernetes architecture, we have seen that container runtime is a component which actually starts the containers as well as manage those containers. Kubelet only instructs container D, and container D will talk to runc, and runc will start the containers. Okay. And as we know from Kubernetes release 1.24 onwards, Docker is no default container runtime engine. We discussed why that's the reason. And okay, so what we will do, we can follow these instructions and install container D and runc. Before that, I want to show one more thing. So when you click on the container D, it will take you to the official documentation of how to install container D. There are various methods you can install container D. You can download the binary zip file and install it. You can install it using apt-get or DNF, or you can install it from the source as well. Okay. So for now, we will go with apt-get methods, and we have Ubuntu instance. There is one instructions here which you need to know. Whenever you install container D with a apt-get or DNF, it will also install the runc, but it doesn't contain a CNI plugin. So that is required. If you see the first option, install it from the official binaries. It is installing container D from a container D binary. Then it is installing runc from its binary. And the third option is it is installing CNI plugin. So what they are saying, when you install container D with a apt-get, it doesn't install CNI plugin. You need to install it separately. So we can go to the Ubuntu, and this is taking us to Docker official documentation. Okay. So you can follow these commands of Docker. The first thing is we need to add Docker apt registry, and then we can install latest version of containerd. So here, just make sure you are only installing containerd.io and not anything else. We don't need Docker buildx plugin, Docker compose plugin, Docker CLI, and etc. So we can go back to our documentation. I have kept all the instructions simple, so you don't need to check this all this documentation. So let's go to our documentation. Okay, so yeah, copy these instructions to install container runtime containerd. There are multiple other options. You can use CRI-O as well. But for now, for our practical, we are going with the containerd. You can copy these instructions to add Docker's official GPG key on your machines. So let me copy paste this. It is adding a GPG key. Okay. Once that is done, you can run sudo apt get to update the packages. Perfect. Run the sudo apt get update command on all machines. Once that is done, the last step is run sudo apt get install and containerd.io from all our machines. So it will install containerd with runc as well, as we have seen. Okay. You can verify whether containerd is installed and running fine with the systemctl status command. Just run the systemctl status containerd and it will show status of your containerd. Okay. We can also enable this containerd. So whenever we restart the machine, it will be always in the enablement mode. Perfect. This is very important thing. You don't really want to miss this part. So we need to configure containerd to use the systemd group. Why? So we'll check the official documentation here, and they have provided the good explanation. Why do we need to do it? Okay. So there are two different C group drivers in our Linux machine. One is C group FS and one is systemd. And as per the documentation, C group FS driver is a default driver in the kubelet. But C group driver is not recommended when we use the systemd as a init system. And we need to have the similar system, similar C group drivers. That's why we need to change it. And additionally, when we use the C group V2, we need to use the systemd C group driver instead of C group FS. Okay, to make it consistent for the kubelet as well as for our containerd, which is a container runtime, both of these components needs to use similar C group drivers. We need to update our containerd configuration to use the systemd C group. So you will find all those instructions here as well. What we will do, let's go back to our documentation only. So we need to load the default configuration first with this command. Okay, containerd config default and load this configuration into one file called etc containerd config.toml. Open that file /etc containerd config.toml, and we need to update certain entries in this file. So what is that entry we need to update? So search for systemd C group parameter. You can just type / and type systemd C group. This is the only entry. So by default, it is set to false. We need to change it to true. Okay. Save this and close this. Once that is done, we need to restart containerd to reload the changes. So type systemctl restart containerd and again verify your containerd is running fine with the systemctl status containerd command. You will see here our containerd is running perfectly fine. So we are good here. The next thing is we need to install CNI plugin. There are different CNI plugins which provides a Kubernetes networking model. Okay, you will find the list of supported CNI plugins here. Sorry. Um, let's see what are other options for the CNI plugin. Sorry. Okay. Yes. One second. So we need to install the CNI plugin, which tells Kubernetes that only supported CNI plugins can be used. So this is kind of rules Kubernetes has set, and if any networking add-on supports this CNI plugin, then only it can be used. So we need to install it. There are no different CNI plugins. Sorry for that. Okay. So I'll install this on all our machines. Disable this for now. Okay. Once that is done, we need to install cryctl. So cryctl is a command line utility which can help us to interact with containers and the images running on our Kubernetes cluster. As we know, Docker is no longer as a default container engine. It has been replaced with supported um, CRI compatible Docker runtime, container runtimes, not Docker runtime, container runtime. So to interact with the images and the containers, we are going to need cryctl. This is another very important command line utility, and you will see this command line utility installed during your CK exam as well. So we are going to check a couple of commands required for us to understand this. Let's is enable the networking IPv4 packet forwarding as well. So I have executed this command. The next thing is we need to install the required other command line utilities such as kubelet, kubectl, and the kubectl. Okay, so I'll copy these instructions and install kubelet, kubectl, and kubectl. Perfect. I think this part is done where all these commands needs to be executed on our Kubernetes cluster nodes as a root user. We have finished 7 steps. Make sure you don't miss any of these steps before jumping into the next thing. Once this is done, what we are going to do, these couple of instructions we need to execute on only on the control plane node, kubeadm config images pool and kubeadm init. Okay. So these commands, kubectl config images pool, it pulls the images required for executing control plane parts, and kubectl init will start a kubectl cluster. So let's copy this file, kubectl config images pool, and so let me disable this option and run it only on the control plane. Once that is done, we will execute the kubectl init command. Okay. Now here you will see that it is pulling some images of the Kube API server, Kube controller manager, Kube scheduler, Kube proxy for DNS, pause, as well as it is going to pull one more image of the ETC. Perfect. Now we can start executing the kubectl command from our control time node, and it is going to perform couple of pre-flight checks and many other options. So on the Kubernetes documentation, you will see here what it does in the init workflow. So it would start our Kubernetes control plane node by executing the following steps. It runs a couple of pre-flight checks before performing other next actions. So it will generate self-signed CA, and it is going to generate certificates for communication, securing communication between different components of Kubernetes cluster. It is going to write a kubeconfig file for the kubelet controller manager and the scheduler, which will be used to connect to API server. Also, additionally, it is going to create one file for Kubernetes admin as and super admin. Okay. And it then will generate a static pod manifest for API server, controller manager, and the scheduler. So what are these static pods? Again, very important question for our Kubernetes interview. This generally get asked, what are the static pods? So static pods are the pods which get started by your kubelet component. Kubelet watches this directory, etc Kubernetes manifest, and whatever the um, files you put into this directory, kubelet will always try to start this. Okay. So that's why we have the manifest file of our API server, controller manager, and scheduler placed into this directory. And kubelet will watch this directory to start the pods of these components. Once that is done, kube-init will apply the labels and turn on the control plane node. So no any additional workloads will run on this. And then it will start generating the token for you, which you need to copy with a kubeadm join command on worker nodes to join. Then it is going to install DNS server and the kube proxy add-ons components via the API server and rest of the things. Okay. Kube init command also takes different parameters. I think for now we don't need them. We are good here. Let's go back to our documentation terminal and see. So if you check the output here, I would highly recommend you to spend some time and check what it has done, kubeadm command in the background. It has pulled a couple of images and then it has started generating certificates, which are placed into etc Kubernetes PKI folder. These are the certificates for your API server to kubelet, communication, etcd, CA server certificates, and then uh, I think API server to etcd client certificate and key. Then it has generated kubeconfig for admin and super admin. It has also generated um, static pod manifest into this directory for API server, controller manager, and scheduler. Then once that is done, it has marked control plane for not scheduling any other workload here for now temporarily. After that, it has started essential add-ons such as core DNS and the kube proxy. So this is a very important part. But they are saying if you want to start using your Kubernetes cluster, you need to run these commands as a following regular user. So just copy these and exit as a root user and run these commands. So what we are doing here, we are creating a directory into home directory .q, and then we are copying the file etc kubernetes admin.config into this home directory .q directory. We are changing the file permission. So once with this file, um, we should be able to access our Kubernetes cluster. If not, we can um, also access the cluster as a root user. For that, you need to export this file with this command export kubeconfig equal to etc kubernetes admin.config. Okay. Yeah. And one more thing you need to notice from this command output, kubeadm output, is a kubeadm join command. This is the command you need to run from worker nodes which you want them to join. So I'll go to my worker node 1 and run this command. Similarly, on the worker node 2, I'll run this command. Okay, so it is saying your node has joined the cluster. You can run kubectl get nodes command on the control plane to see the node join the cluster. Can I do the kubectl get nodes on this node and see if I get output? No, it is giving me some error. If you see here, what it's saying, couldn't create a current API server. Okay, connection refused. So deduce this by the right host or the port. But if we do run this command, similar command from our, let me exit as a root user and run it from our control plane node, we are able to see our control plane node and worker nodes as well. Why this is happening, right? Because we have this file into directory, it uh, home directory .cube config. This is a file where the kubectl command checks, and if you have the valid kubeconfig file, then only you will be able to access Kubernetes server and interact with your API server. Since we don't have this file present on our nodes, we won't be able to access our Kubernetes cluster. See, it is saying no such file or the directory. I hope this is clear. Which means if you want to access this Kubernetes cluster from outside your control plane node, then you need to copy these files into that node into this directory only, or set the kubeconfig file environment variable into respective directory, and then you can access it. Okay. But let's see, our nodes are showing not ready. So we need to add one more command. We need to install network add-on, which is compatible with our CNI plugin. So we added a CNI plugin here, which is just an interface for your network add-on and the Kubernetes cluster. There are multiple different CNI network add-ons. You will see the list here: ACI, Cilium, Canal, Flannel, then ViewNet, and multiple others. So for this exercise, we are going to use ViewNet. Okay, so let's run this command, which will install all the components of our ViewNet network add-on. Let's copy this and so copy this command and execute these on the control panel. We can execute this command as a non-root user since we have the config file here. Perfect. It is going to create a service account, cluster role binding, role binding demonstrate for us. And now we should be able to see cluster nodes are in ready state. This is great. So we can also run the kubectl get pods command to check the list of the pods. Since there are no pods in different namespace, the list is empty. But we can add one more option, hyphen capital A. It will show the pods running into different namespaces. All pods are running state. Okay, this is great. We can execute um, we can deploy sample app. So we will run the sample app in Nginx and try to access it. Okay. So our pod is ready. We can check that using kubectl get pods. Now you will see Nginx pod is getting started. We can also check the services as well. This cluster and our service is also running. So our Kubernetes cluster is ready to be used. This is good. Uh, I want to add or share a couple of more commands. If you miss the kubectl join command, then you can create a new token using kubectl token create print join command and use it with any new worker node as well. If you miss any of these steps to follow, then you can reset kubectl input init uh, command output with a kubectl reset, which needs to be run on all the nodes of your Kubernetes cluster. and it will reset everything done by the QBD. Okay, perfect. So don't worry. If you face any issue, let me know in the comment and I'll try to answer all your queries. I hope you are enjoying this free CK series and please support. If you like this, please like this video, please like, share, subscribe, and share with your friends. I will create more such informative videos. This will not only help you for your CK exam, but it will also help you for your Kubernetes interviews as well. So make sure you are watching these playlists regularly. And yeah, thank you. Bye.